This is a continuation in a video series on the Ralph steam engine. In this video, we are machining the flywheel for the steam engine. Construction notes describing the part and the machining operations can be found at the Eclectic Builds website, listed in the description. The flywheel on a steam engine plays a very important role. During a piston stroke in the Ralph steam engine, steam fills the cylinder when the piston is at the top of its stroke. The pressure and expansion of the steam in the cylinder forces the piston down. Ralph is a very simple engine, and to ensure that the piston returns at the end of its stroke back to the top of the cylinder, we need some way to cause the piston to return again. The flywheel provides a mass that ensures enough rotational momentum is applied through the crankshaft to return the piston to its starting position. In other words, the flywheel keeps spinning even when the steam is not present and completes the other half of the cycle. All of that means that we want a fairly hefty little flywheel, but one that does not look out of proportion to the rest of the steam engine. To balance out the weight and size constraints, we are using a piece of round, cold-rolled steel as the stock for machining the flywheel. In our case, it is 3 inches in diameter. A boss, or spigot, is turned on one side of the flywheel. A profile is cut into the sides of the flywheel, mainly for aesthetic purposes, so it looks like a flywheel rather than a lump of round steel. A hole for the axle is spot drilled, then drilled out, and finally reamed to size. A little finishing with the lathe file rounds over the edges of the boss. A V-groove is also cut, allowing a thin belt to be attached to the flywheel to drive a generator. The flywheel is flipped around so the other side can be faced and profiled like the first side. flywheel is tested using a drill bit as a temporary axle to check that the flywheel is visually running true. A hole for a grub screw to secure the flywheel to the axle needs to be drilled at an offset of 20 degrees. In this case, the tilting table on the drill press is the simplest way to set this up. The drill is used to peck at the boss on the flywheel to get the hole started and is then drilled out. A tap follower is inserted into the drill chuck without moving the setup. This keeps the tap wrench nice and square to the original hole and helps prevent breaking off this small tap, which would be a tragedy at this point in the machining of the flywheel. Please like this video to increase the number of people who will get to see it. And if you'd like to see the Ralph steam engine come to life in further videos, hit the subscribe button.